All right, I'm going to talk to you real quickly about how we can test validity using truth tables. So if we take an argument, like let's just take something I know is valid, and we have like this argument. It's A horseshoe B, A, and conclusion is B. Usually what we'll do is we'll write each premise, we'll separate them with a little line, and then we'll put 2 lines there for the conclusion. Now in this case, this is going to be really simple. I wanted to keep it simple because I don't want a huge, long argument. This is called modus ponens. So we have 2 letters. So we need 4 lines. 2 to the power 2 is 4. So we'll put true, false, false. And then for B, I'll put true, false, true, false. Now make sure A matches, and that was true, true, false, false. And B was true, false, true, false. Now, this one, we already know what the main operator for this statement is. We already know, the main operator. There is no main operator, it's just a letter. So the only one we're going to have to do is we have to find out what this one is, right? So true horseshoe true is true. True horseshoe false is false. False horseshoe true is true, and false horseshoe false is true. Now, what happens is if you remember a deductive argument is one in which if the premises are true, then the conclusion necessarily must be true, right? So if the premises are true, the conclusion must be true. So what we want to do is we want to find a line in which we look at the premises. And if all the premises are true, and there's only one line in which that occurs, and that's this one, then we want to know if those premises are true, is the conclusion true or false? If it's true, then that's at least evidence that it can be valid. But if you have any line, a single line in which the premises are true and the conclusion is false, if that had been false there, then we would label this invalid. So all you're doing is you're just doing a normal truth table, same as you've done before for all of it, and then you're going to look for a case where the premises are both true, and you're going to look for a false conclusion. Now in this case, this one doesn't have one, so it's true. Now, is it possible that an invalid argument could have true premises and a false conclusion, or I'm sorry, a true conclusion on one line? Yeah, but if there's ever a case where there's true premises and a false conclusion, then we have to label it invalid, because in this case, we see that we have true premises and a false conclusion, and true premises necessarily must give a true conclusion. So you can't have the existence of a line like this. And so the existence of a line like that proves it invalid. So what you do is you do the truth table, and then you look only for ones if there's a line here, like this one has a false, so don't care about that line. True, but this one's false, so don't care about that line. And then this one, false, and that one's true. Don't care because one of the premises is false. The only thing we care about is one in which all the premises are true, and then we want to look at the conclusion. If one has true premises and true conclusion, doesn't mean it's invalid. It only means it's potentially invalid. But if one line has true premises and false conclusion, then it is invalid. So let's just do a quick example of an invalid argument. And let's say A horseshoe B, bar or tilde A, and then the conclusion is tilde B. This is what we call affirming the, negating the antecedent, and it's a formal fallacy, which we'll talk about here in our next week's lesson. But I'll go ahead and show it to you here. What you do is you do it just like you would do true, false, false, true, false, true, false, and then you go true, true, false, false. You have to make sure the A matches, right? And then you have to negate that, false, false, true, true, cross that off. And then this one, I suppose I should have written this in before I started doing that. You have true, false, so that becomes false, true, and we can cross that off. So this is our, kind of the one we're looking at to compare, okay? And then we're gonna go true, horseshoe true is true, true horseshoe false is false, false horseshoe true is true, and false horseshoe false is true. So we'll go ahead and circle this one. If you want to cross those out, you can, but you don't have to. And then we're gonna look and we're gonna go, okay, true, false. Don't care about that because they're not both true. False, false. Don't care about it. They're both not true. But here we have true, true, and we have true, true. But in this case, if you look, the bottom line has true premises and a true conclusion. Does that make it valid? No. What makes it invalid is the fact that on this line, you can have invalid, or you can have true premises and a false conclusion. Since it's possible to have true premises and a false conclusion, we know that this is an invalid argument. Typically, you wouldn't circle this that doesn't prove invalidity. You only circle it when it does prove invalidity. Now, you'll be doing this on a computer, so you wouldn't necessarily make any difference to you because you won't be circling anything, but at least that's the way it's normally done. All right, I hope everybody is happy, and if you have any questions, let me know. The problems get a lot more complex than this, and that's fine. You know, I just wanted to kind of give you a brief example here, and if you have any questions, you know, raise your hand or send me an email, okay? All right.